Welcome to the new chapter of 10th class mathematics, linear equations in two variables. So let us begin first by looking at some of the real world examples where we use linear equations in two variables. So assume today is the first day of school and the teacher in a classroom asked her students what was the cost of the book and a pencil that they have bought. So Raju gets up and says that he bought 3 pencils and 2 books for 80 rupees. Then Sita gets up and says she bought the exact type of pencils and notebooks, but just that she bought 4 pencils and 3 books for 110 rupees. So no one really has answered the teacher's question, where the teacher was asking what was the cost of individual pencil and the individual book. All they knew was the total amount that they paid for a group of pencils and a group of books, but they didn't know how much they paid for each pencil and each book. So in order to help the students solve the problem, the teacher then compares the two cases. In the first case, Raju said 3 pencils and 2 books for 80 rupees and Sita said 4 pencils and 3 books for 110 rupees. So the teacher then replicates the same number of pencils and the books that Raju bought 2 times. Right? So as you see here, now in total we have 1, 2, 3. She replicates it 2 times. So that makes it total of 9 pencils and 6 books for 80 plus 80 plus 80, 240 rupees. So in the next case, for Sita, she replicates the entire order by 1 time, which then makes the total number of pencils equal to 8 and the total number of books equal to 6. So if you observe now, what the teacher essentially did was she made the number of books equal in both Raju's and Sita's case. So now we have a total of 9 pencils and 6 books for 240 rupees and 8 pencils and 6 books for 220 rupees. So now let us subtract these two. So we have total of 8 pencils here and we have total of 9 pencils here. So 8 and 8 get cancelled out. And then we have 6 books and 6 books, so both of them get cancelled out. So you will be left with 1 pencil and the difference, which is 20 rupees, right? 240 minus 20 is 20. So 1 pencil costs 20 rupees. So having calculated the cost of the pencil as 20 rupees, now let us calculate the cost of the book. So we know from Raju's case, 3 pencils and 2 books costed him 80 rupees. So the cost of each pencil is 20 rupees. So 20, 20, 20. So this is total of 60 rupees for the pencils. So that means for the cost of the books, in this case the 2 books is 80 minus 60, which is equal to 20 rupees. So 2 books cost 20 rupees, then 1 book costs 10 rupees. So now we also know the individual cost of the book, which is 10 rupees. So we started with 2 objects, pencils and books, and we didn't know the individual prices of those, but we ended up finding the price of the individual pencil and books by following this method. So basically the same scenario can be expressed as linear equations in 2 variables as follows. So let the cost of the pencil be x and the cost of the book be y. So in first case, we have 3 pencils and 2 books for 80 rupees. So 3 times x plus 2 times y is equal to 80 rupees. In the second case, we have 4 pencils and 3 books for 110 rupees. So 4x plus 3y is equal to 110. So in general, a linear equation in 2 variables is expressed as ax plus by plus c equal to 0, where a, b, c are real numbers and at least a or b is not 0, because if a or b is 0, then this becomes a linear equation with 1 variable, because x is 0, then we will be left with by plus c equal to 0, but that means it's only a linear equation with 1 variable. Same thing, if y is 0, then it becomes ax plus c equal to 0, again it is a linear equation with 1 variable. At least a or b should not be equal to 0. C can be 0, but a or b cannot be 0. So in this case, the same equation can be written as 3x plus 2y minus 80 equal to 0, which is in the form of ax plus by plus c equal to 0, where a is 3, b is 2 and c is minus 80. So this is the general form of representing linear equations with two variables.